this is a pre-calculus review. First thing we need to review is the graph of the polynomials and basic inequality like this. Okay, so let's start with the simple polynomial first. Find the zeros of polynomial. What are the zeros? Zeros are whatever makes this y value equal to 0. Another way of saying that is x squared minus 2x minus 8 is equal to 0. Solving this equation is equivalent of finding zeros of any function or this particular function. Let's review factoring briefly. So we have x here and x here, and 2 and 4 will do, and then we need to decide which is negative and which is positive. My habit is I write everything with negative and decide that one is positive. That is equal to 0, meaning this first term is equal to 0, therefore x is equal to negative 2, or the second term is equal to 0, therefore x is equal to 4. Okay, we'll start graphing this thing now. So x is equal to negative 2, then my y value is equal to 0, so one of the coordinate happens to be right there at 0, 2. 0, negative 2. Okay, and the other point, when x is equal to 4, my y value is equal to 0. As you can see, if I substitute 4 here, then that term becomes 0. So the other one is right there. Okay, so that point is, my bad, this is negative 2 and 0, and this is 4 and 0. Now, this is a parabola. It's going to look roughly something like this, but this is ugly. We're taking calculus now, so can we be a little more exact? Let's quickly review the behavior of quadratic functions, parabolas. I have a parabola here, y is equal to x squared, and even if I vary or move it around, you notice that the shape does not change, and our parabola happens to be exactly this one right about here, isn't it? Okay, going through negative 2, 0 and 4, 0, and the shape itself did not change, so we can use this. So next thing we have to figure out is the axis of symmetry, this thing being symmetrical and 3 spaces, 3 spaces. So this must be axis of symmetry. Now halfway through, so this is 3 here. So let's quickly look at this. F of x is equal to x. I'm gonna write it as g of x. And then you notice that when x is equal to 3, this is 9. So if I have 3 spaces, I need to go down by 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8. Ran out of space. 9. Right there is my vertex. And the other thing, so that it happens, is that let's think of it as a slope of a curve. 1, 1, and then 3, and then 5, and then next one will increase by 7. So we can use this fact to graph this thing pretty fast. 1 here, so if x increases by 1, y increases by 1. Then x increases by 1 and y increases by 3. And the next one, x increases by 1 and y increases by 5. And next one will be 7. Okay, and use the symmetry to plot these other points right there. Now, let's not make this part, although it's called the vertex, that's a misleading term. It shouldn't be pointy. It is a big deal in calculus that this needs to be flat. And then you're looking at the next point and using line segments, tiny little line segments. And then let's graph it like this. Okay, so this is a nice looking parabola, which is exactly same as what I have with computer. Now, okay, so we found the zeros, couple of them. So our zeros are -2 and 4. Okay, you might have been doing this, but this is incorrect notation. X itself is not a set. Okay, so this is a set of zeros, so it's more correct if we just write zeros, colon, and the set bracket. Okay, now, then it says find the interval where the function is increasing and decreasing. Well, it depends on the direction that you're traveling. If you are going to the right, then this part is decreasing. Think of it as a roller coaster. You're going down and then going up. Well, that's the opposite if you are traveling to the left. So what's going on? How do we know which way it is? Well, in Western culture, we write from left to right. This is a negative x-axis and positive x-axis. So let's all agree that we are traveling to the right. Then this roller coaster ride is first going downhill, then uphill. So it's decreasing that much and increasing right there. Okay? So let's write the function f is increasing, decreasing, and let's review the interval notation. Instead of saying x is equal to less than or equal to, right there, 1, right? Instead of that, because we'll be using interval notation a lot, so from negative infinity all the way out here, all the way to positive 1, which is our axis of symmetry, and then f is increasing on from 1 to infinity. Okay, now some of you are probably wondering, why did I include 1 here? Shouldn't that be parenthesis? It really depends on who you ask and which book that you are reading. But most books say it's I don't want to get into it right now, but some long and complicated and somewhat stupid reason that they want to include it when you define a function as increasing and decreasing. And yes, I know it looks like that the function f is increasing and decreasing at the same time when x is equal to 1, but it is what it is. That's how it's defined, okay? Then in this case, we call this point right there minimum. Okay, so our minimum is having a little trouble. Our minimum is, now this is incorrect because maximum and minimum is a y value, so we should not do that. One way to do it is give a coordinate, -9, like that, or better yet, give a function notation. Okay, so either this or that. Okay, now then part B, we have to solve this inequality. Okay, so notice this part right here is exactly same as our function, and we're going to use this graph to solve this inequality. So the question becomes, for what x value is this whole thing is my y, f of x here, my y coordinate positive. And as you can see, y coordinate is positive here, it is 0 here, negative here. For example, this point happens to be 2 and -5. See, y coordinate is negative. So it's negative all the way here, and then now it turns into positive. So this, if we use this idea and use zeros, this inequality becomes so much easier if you have some kind of idea what this graph looks like. So I want my y coordinate to be positive. In order to do that, I am looking at this section right here and this section right here, correct? So my x value has to be positive. So my x value that I want is this part and this part. Okay, so we can say this is true. And also, once again, well, first write it like this. X is less than or equal to -2, or x is greater than 4. But calculus books, once again, prefer interval notation. So instead of that, we rather want to write this part is negative infinity and that part is positive infinity. So between negative infinity to negative 2. Okay. Now I want you to try this example. It's exactly the same problem as before. I want you to pause this video and work on it, then resume in order to check the answer. Okay. Now we're back. So let's first find the 0 by setting this function x squared plus 4x minus 5 is equal to 0, and let's factor. So we have x is here, and then 1 and 5 will do, except this time this needs to be positive. So we have x is equal to 1 or x is equal to negative 5. Okay, let's plot those two zeros first. So we have positive 1 here and negative 5 right there. And like before, axis of symmetry happens to be exactly in the middle. So the x increases 3 this way. Coincidentally, I picked the problem that is exactly same amount, and I'm going to run out of space again. So this is 9. So this way, if I increase x by 3, then this will be increasing by 9, 3 squared. Okay. Now, so using exactly same tactics to plot this, first increase by 1, then by 3, then by 5. So my graph will look like this. Like that. And the other side. One of the tip of sketching this thing is if you start from the vertex and where it's flat, then it turns out to be a lot prettier. Okay, so like that. Okay, now then let's say f is decreasing right here, this part. So on negative infinity to this time negative 2, and f is increasing on starting from negative 2 and all the way to infinity. Okay, therefore we'll have minimum again. So our minimum happens to be right here, okay, which is negative 2 and negative 9. So negative 2, negative 9. How about that? Or better answer, well, equivalent answer, function notation. These two mean exactly the same thing. Okay, now let's solve this inequality then. If I say x squared plus 4x minus 5 is negative, then I am looking for wherever my y value is negative. That happens to be this part right here, isn't it? So in order to satisfy that, my x value has to be in between here. Okay? But this time there is no equal sign, so we have to exclude this point. So this is the only part that satisfies the inequality. So my x has to be in between negative 5 and positive 2. But interval notation of that would be, and it's unfortunate that this looks like coordinate, but this is an interval notation. Okay, here's another problem. So once again, I want you to pause this video and work on it, then resume in order to check the solutions. Okay, hopefully you have got this one right. So let me work it out for you. Negative x squared plus 2x plus 3 is equal to 0. We could factor it the way it is, but it's so much easier if you multiply negative 1 on both sides. So let's just do that. So multiplying -1 on both sides like that, and 0 doesn't care if we multiply -1 on both sides. So this becomes x positive x squared minus 2x minus 3 is equal to still 0, and of course that factors to 1 and 3, and this is positive now, isn't it? Okay, so x is equal to -1 or x is equal to positive 3. Okay, how about that? So let's plot those here. So we have -1 here and positive 3 here. Now one thing we have to be careful is this function starts with a negative sign. Meaning, for example, if you plug in -100, this is 100 squared, so we have -1,000,000 plus 200 plus 3. That's still a pretty small number. So this thing will flip over and invert it. Okay, so here axis of symmetry is right in the middle, and this graph will look exactly same as y is equal to -x squared. So if I plug in 2 here, then it will be 4. So it will be 1, 2, 3, 4. That is where my vertex is. I'm not sure if you got that, but so let me call this h of x before the transformation, x squared, -x squared. And if I plug in 2 meaning this way is by 2. So how much do I need to go down? And that's -2 squared, which is 4. So this is going down by 4. Okay. Now, using our pattern, going down by 1, and then 3, and then by 1, 2, 3, 4, 5. Like that. So my parabola will look like this. Okay. Now then, we have our function increasing first from -infinity to +1, and then decreasing. So let's write that down. So f is increasing on from -infinity to +1, and f is decreasing on +1 to infinity. Okay. Now, therefore, we are going to have a maximum now. This point right there is my maximum, which is 1, 4. So we have max at 1, 4. Or we write it like this. Oh, g. My function is called g. G of 1 is equal to 4. Okay. Now, how about the inequality? Inequality, we have to be a little careful because we have this negative sign that we are starting with. So let me write that down. Negative. Change the color. -x squared plus 2x minus plus 3 is positive, meaning my y value here of this function needs to be positive. So looks like we are looking at this part right here. This is where my y value is positive, and so we can say this is true when x is between -1 and +3. It's basically between these two zeros. These zeros tell us a lot of information about this behavior of the functions. So putting in interval notation, I'll do it both ways. So when x is between -1 and +3, also known as this -1, comma 3 in interval notations. Now we have this problem. So once again, I want you to pause the video and work out this. The factoring is a little more difficult, but let's try it. and then resume in order to review the solutions. Okay, did you get it? Okay, let's just review the factoring of this thing first. So we have 2x squared minus x minus 10 is equal to 0. To find the zeros, now this 2 is throwing you off a little bit in case you are a little shaky with factoring, but let's say that has to be 2x and an x. Now what other combination can I put in here in order to have difference of negative 1? For example, if I put 2 and 5 here, then this term will give you 2x and this term will give you 10x. And the difference is too big to come up with negative x. So what we have to do is 5 here and 2 here. That way this term gives you 5x and this term gives you 4x. Okay, do you see that? So as long as this is negative and this is positive, then we'll end up with a negative x. Okay, so I need this to be negative and this to be positive. Do you get the idea on how to factor this type of quadratic? Okay, so then this term needs to be 0 or the other term needs to be 0. So here I get x is equal to 5 over 2 or x is equal to negative 2 now. Okay, let's graph that. In order not to make the same mistake twice, I haven't put any axis here, and I happen to know that this thing goes down pretty low. So I'll just throw the axis like this. Okay, let's just throw it somewhere here. That didn't work. Hold on a sec. Okay, so that's my x-axis. And my y-axis, let's say somewhere in the middle, right there. Okay, let's say that's my y-axis. Be sure to use graph paper whenever you graph anything. Okay, so we have 5 over 2, which is 2.5. So 2.5 right here is one of my 0 and the other one is negative 2. Now, axis of symmetry is pretty difficult here, therefore, and this function will not follow our usual pattern, and besides we have this 2 in front here, so it will make our process pretty difficult. But axis of symmetry halfway between the two. So this space is 2 and this is 2.5. So do you see that axis of symmetry has to be quarter right here when x is equal to 1/4? Right there, x is equal to 1/4 is our axis of symmetry. Okay, the other little piece of information that we can use is when we substitute 0 here, 0, 0, we have negative 10. So negative 10 is down here. It has to go through that point. Therefore, it has to go through that point by symmetry. I was off a little bit. That point right there. Okay. Now, let's calculate the vertex. Okay. The way you want to calculate the vertex, we have no other choice but by plugging in h of 1/4. 1/4 for x. So we have 2 times 1/4. My pen is not working. Squared minus 1/4 minus 10. Okay, that happens to be 2 times 1/16 and minus 1/4 minus 10. So this is 2 over 16, which is 1 over 8 minus 1/4 minus 10. Let's figure these two out first. This is negative 1/8 and minus 10. So what we get is 10, negative 10 and 1/8. How about that? Oh, that was pretty difficult. Negative, so we have positive 1/4 and negative 10 and 1/8. Okay. Now then, we can figure out, well, let's roughly sketch this parabola. So it'll look like this, and the other side go up and look like that. So we can say f is decreasing on the left half on negative infinity to 1/4, and f is increasing on from 1/4 to infinity. Okay, therefore we have our minimum at 1/4 and negative 10 and 1/8. How about that? Okay, now the inequality part. So let's say this function 2x squared minus 4x minus 5 needs to be positive now. So positive meaning I want this part and this part. Okay, so my x value happens to be right here and right here in order to make my y value positive. So the solution to that would be, this is negative infinity and this is positive infinity. So negative infinity to negative 2, parenthesis in order to exclude that point boundary, and union that with the other one, 5/2, all the way to infinity. Good. Hopefully this wasn't too much for you. Okay, this is another day of reviewing polynomials, zeros, and graphs, and of course inequality. But this time our function is a lot more complex. So let's review what this thing looks like. Number one, as always, we'll find the zero first. So zeros of the function x cubed minus 3x squared minus 4x plus 12 needs to be 0. Okay, where the function becomes 0, it's a critical piece of information in this business. This technique is called the factor by grouping. So what we are doing is group this first two and this last two separately, and look for the common factors here. So first one looks like x squared is a common factor. So x squared, and what's left is x minus 3. And here, let's factor out negative 4. You always want to include that negative sign with the common factor. So negative 4, and then x, then it's minus 3. That way, when we distribute this, negative 4, you get negative 4x, and then positive 12. Got that? Now, then looks like x minus 3 in the parenthesis is a common factor between this term and that term. So let's factor that out. So we have x minus 3. Then we have x squared minus 4 is equal to 0. Let's look at that one more time. Backward thinking, if we distribute this thing here, you get that term, and this whole thing here, you get that term. Good. Now, this thingy is what's known as difference of square, and it's a nice little formula in case you still don't know them, as a squared minus b squared factors out to be a plus b times a minus b, something you need to remember from algebra 2. So we have x minus 3, and then this term x minus 2 or plus 2, whichever, x minus 2 is equal to 0. So looks like this term will give us x is equal to 3. This term will give us x is equal to negative 2. And this term will give us x is equal to positive 2. Okay, so my zeros are in ascending order. So we have negative 2, 2, and positive 3. Okay, let's plot those. Okay, now this one, I'm just going to put it in the, I have y-intercept to be 12, right? But I'm going to rescale the axis now because it's very difficult to see what this function looks like. So we just need an approximate sketch. So let's throw the axis right there in the middle, like that. Now let's start plotting. So we have -2 here, and then +2 here, and 3 here. Those now. Notice that this thing starts from positive, meaning it's going to come down up there from heaven in that direction. Okay, so now this function has to go through these 3 points. So only way you can do that is it goes through this point, quickly turns back around, goes through that point, and then it has to go through whichever is 12. Okay, let's rescale this thing and say this is 4, 8, and 12, something like that. So it has to go through that point somewhere. Okay, now it's pretty difficult for you to know how high, where that peak is. And that's where the calculus comes in. But it has to go through that point somewhere. So let's just say goes up, 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 up like that. And then it will go through this point. And at some point, which we will not know where that maximum is, and come back down. And that's the rough sketch of this function. Okay, and notice that I did not have you find the maximum or increasing, decreasing interval here because that requires calculus lessons. Okay, and this is a review of pre-calculus so far. Okay, but we can still solve this inequality. Okay, let's look at it. I want my y value, or this whole thing is my function f of x. I want my y value, y here, to be negative. So in order for that to happen, I have to take this part right here, and then I have to take that part. So my x value that gives me is this part and this part, isn't it? So solution to that inequality is, this is -infinity once again. So -infinity to -2. Maybe I should just throw in equal sign for a change, right? Okay. Suppose there was an equal sign, so like that, union, as well as between these two, right there, right? Which is 2 and 3. So I want to fill in this dot. How about that? So inequality part is pretty easy if you have some rough idea of what this function looks like. Okay, and in case you are not required to give an exact graph, this is what I would have done. Just plot these functions, say -2, +2, and 3. And this function has to behave something like that. So this part is negative, this part is positive, this part is negative, and this part is positive. So if I want this to be negative, all I have to do is take this part and that part. Okay, hopefully that's clear for all of you. Okay. Now we have this exercise. Similar, but I want you to pause this video and try this. And we'll resume afterwards. Okay, we are back, and hopefully you have figured this thing out. Let's first find the 0. So x to the 4th minus x cubed minus 12x squared is equal to 0. And this is slightly different than what we had before. And in all factoring, you should look for common factors first, and looks like x squared is our common factor. And then we have x squared minus x minus 12 left. Okay, and this part factors inside, so we have x squared, and we have 3 and 4. Once again, we'll write both of them as negative and decide which needs to be positive. And sure, looks like this is negative, so this needs to be positive. Good. So our zeros are x is equal to 0. However, there are two of them stuck here, which is known as multiplicity of 2. Hopefully you remember that part. Multiplicity 2, and I'm going to tell you how the graph behaves right there. And x is equal to -3 or x is equal to 4. Okay, so our zeros are in ascending order: -3, 0, multiplicity 2, and 4. Okay, now what does the graph of that thing look like? Let's sketch it right here. Okay, so we have -3 here, and 0 here, and 4 here. Okay, now you might be thinking, well, that's easy then, right? It comes down here and goes back here and goes down there that way. Okay, nice and swell. Not so fast. This is fourth degree function. And then you may remember that in fourth degree function, this side goes up as well. Let's quickly talk about that here on the side. This is a first degree function. Second degree function looks like this with a positive leading coefficient if it starts with a positive. If it starts with a negative, then first degree looks like this, and second degree looks like that. And third degree, if it starts with a positive, will look like that, or if it starts with a negative, then it's going to look like that. Notice that I always start sketching it from the right hand side. So the fourth degree will look like this, or look like that. So this is our case right here. Both of this end points up. Now we have a problem. Okay, the problem comes out because we have neglected this multiplicity of 2. So we have to make that adjustment. So it happens, this function will come down from top like that. And until we study calculus, we have no idea. And then also this side has to be like that. Okay, now it has to turn around a few times and have a approximate W looking shape. And then everything has to merge here. If there are another 0 here, let's say if there's another 0 here, then it'll do this, and that would be nice as well. Except we don't have that 0 there, so everything has to merge onto that part, and turns out it just bounces this thing off, and probably this end is lower, somewhere down here, and this is the shape of the function. You really want to check this out with Desmos, okay? So this is the general shape of the function. Now then we can do inequality. So inequality of this is x to the fourth minus x cubed minus 12x square needs to be positive. Positive meaning this part right here, okay, and this part right here, okay. For the sake of interest, make this problem a little more interesting. I'm gonna throw negative equal sign right there as well, okay. So, or this needs to be 0, and 0 is right there. So I want to include those points. How am I going to present this? So x value, this part, that part, and that 1 point right there. So once remember, this is negative infinity and this is positive infinity. So my solution has to be negative infinity to negative 3 bracket union, and then there is no such thing as this, right? So we cannot write the singleton 1 point with the interval notation, so we have to go back to set notation and 0 here, and then union that with the other point, which is 4 all the way to infinity. How's that? Okay, now we have this function. Okay, I want you to try this. Once again, pause the video, and then we'll go over the solution together. Okay, we're back. Hopefully you have figured this thing out. Let's see, x to the fourth minus 10x squared plus 9 is equal to 0. Let's work on those zeros first. And some of you might have noticed this is quadratic form. This is x squared square. And so we are looking at x squared as just regular x. And let's factor it that way. So we have x squared here and x squared here. Okay. Now 9 and 1. Like that. It's a correct factor and they're both negative this time. And then both of these are difference of squares. So it will work out to be x plus 1, x minus 1 here, and then x plus 3, and then x minus 3 here. Okay, so our zeros are, let's just write it with negative 3 ascending order and negative 1, and then positive 1 and positive 3. Okay, let's start plotting those. Let's put it somewhere here. Okay. So we have negative 3, negative 1, and positive 3. Okay. Once again, this thing started with a positive sign, so it will come down from here, go through this point, and this time it will behave pretty normally and go through that point. Now our y-intercept is 9. Well, let's rescale this and call this thing that point 9 right there. Okay, and this thing is pretty symmetrical, so it will go through that point, come down, and go up like that. So this is approximate sketch of this function. It's probably a lot lower here, but until we take calculus, there's no way for us to know. Okay, now let's solve the inequality. Inequality x to the fourth minus 10x squared plus 9 is less than or equal to 0. Okay, so I want my y value to be negative. Negative is here and here, this part, or equal to 0. Okay, like that. So my solution to that happens to be bracket negative 3, negative 1, union, and 1, bracket here, 1 to 3. How's that? Okay. Our final example, our final exercise. Okay, this is a bit more complex, so I want you to try this, and then we'll talk about it afterwards. So pause the video once again and try this. Okay, we're back. So let's find the zeros first. X to the fourth minus 3x cubed minus 8x plus 24 is equal to 0. So we'll try factor by grouping. Hopefully that will work. So we'll group these two and we'll group these two together. Okay, now so we have, looks like x cubed is a common factor between the two. So we have x minus 3 and negative 8, and then we have x minus 3 again. So looks like factor by grouping will still work. And common factor here is of course this term and that term. Okay, so we have x minus 3 common factor, then we'll have x cubed minus 8 is equal to 0. Okay, that's nice and swell. Except what does that thing? How does that factor? So here's another review from algebra 2. It's known as difference of the cubes. I'm gonna write it up there. So a cubed minus b cubed turns out to be a minus b, and then a squared plus ab plus b squared. Okay, the other one is there's a sister, a cube plus b cube. See, only the difference of the cube, a squared plus b squared didn't factor, but this one does factor. And this one turns out to be a plus b, and then a squared minus ab plus b squared. Okay, you might want to note these two. So this thing factors with x minus 3 here, and then x minus 2. See here, our b cubed is equal to 8, so our b is equal to 2. So x minus 2, and then a squared, a is x, so x squared now times ab. So that is 2x and plus b squared plus 4 is equal to 0. Okay. Now, so far we have x is equal to 3, x is equal to 2, and what about this? Okay, this thing does not factor, you can try, so we use quadratic formula. So x is equal to negative b plus or minus square root of b squared, 4, minus 4 times a times c over 2a. Okay, now that turns out to be negative 2 plus or minus, that's 4 minus 16, isn't it? We are looking at complex numbers, and hopefully you still remember complex numbers. Okay, unless we have to simplify that. So negative 2 plus or minus, see, negative 12. 12 is 4 times 3. So square root 12 is square root 4 times square root 3 now, isn't it? And this one is 2, and this one is still square root 3. And then of course we have negative sign, so negative sign is I here. Probably your pre-calc book put the I at the end, so we'll say 2 root 3 I over 2. Okay, now then this 2, let's separate the fractions. So this way, negative 1 plus or minus, and that 2 cancels, so root 3 I. How about that? So my zeros are 2, 3, and complex number 1 plus or minus to the root 3i. Okay, let's plot these things then. And you might be surprised on this. So let's throw the x-axis somewhere here. And y-axis somewhere here. Okay, so we have 2's here, 3's here. How do we plot this complex number? They are not even real. Well, so therefore there are no real zeros. These are complex zeros, so we cannot plot them. So this is it. And so this very narrow skinny function, starting with positive, so it'll still come down from here, and then it'll quickly turn around and go back up, and it'll go back up to y-intercept being 24. We are not going to bother to plot that one. Okay, this is it. So you might say, well, doesn't that look like parabola? No, it doesn't. It's a lot steeper, sharper than parabola, and it may not be exactly symmetrical either. Okay, but we can nevertheless solve this inequality. So that inequality happens to be, so let's write it here, x to the fourth power minus 3x cubed minus 8x plus 24 needs to be less than or equal to 0. So graphically, less than or equal to the y value needs to be negative, so we're just taking this part right there. So my x value, as long as x is between 2 and 3, I'm good. So that should be between 2 and 3, and that's it. And notice that these complex zeros did not contribute to this inequality at all. Hopefully this was beneficial to you.